Now let's discuss about the reverse osmosis. So what is the concept of osmosis? Let's first discuss about the concept of osmosis. Then we are going to discuss about the reverse osmosis. The word osmosis is originated from the Greek word which is a osmos, right? So osmosis is a derived from Greek word which is a osmos, and osmos which means to push, right? So osmosis is a natural phenomena most commonly observed in plant. If we do not water our plant, they wilt. A plant cell is a semi-permeable membrane with living stuff inside in salt solution. Water is a draw into the cell from outside because pure water move across the semi-permeable membrane to a dilute high concentration of salt inside. This is how water is drawn in form of groundwater when we water to our plant. On other hand, we add salt to plant, the plant wilt because the salt concentration outside of the cell membrane becomes the flow of water from plant to the outside of the surface of the plant, right? That's why plant will be wilt. So osmosis may define as a physical movement of solvent. Osmosis is defined as a physical movement of a solvent or water through a semi-permeable membrane based on difference chemical potential between two solutions separated by the semi-permeable membrane. Let's take simple example to demonstrate the osmosis. Let's take this beaker or this type of arrangement in which water, one side there is a water and second side there is a concentrated solution such as a water plus NaCl. So water is flow from pure side to the concentrated side because chemical potential of pure water is a higher, right? For the pure component, chemical potential is always high than the impure substance. That's why this flow is go from higher chemical potential to lower chemical potential to equate this chemical potential, right? Therefore, in effort to equilibrium the difference in chemical potential, water being to diffuse through a membrane from the water side to salt water side. This movement is known as a osmosis. The pressure extracted by the mass transfer is known as a osmotic pressure. The difference of water will continue until one of the two constraints is met. One constraint would be that solution essentially equilibrate at least to the extent that remaining difference in chemical potential offset by the resistance or pressure lost by the diffusion through a membrane. The other constraint is that rising column of salt water exert sufficient hydrostatic pressure to limit the further diffusion, right? So it has further power or considered sufficient hydrostatic pressure to limit the diffusion. By the observation then we can measure the osmotic pressure of solution by noting the point which head pressure not by the in chemical not by the in manometer, right? Concept of now let's discuss about the concept of reverse osmosis. Reverse osmosis is a less commonly known as a hyperfiltration, is a high pressure energy efficient technique for dewatering process and stream, concentrating low molecular weight substance in solution and purifying waste water. It has ability to construct, dissolve as well as suspended solid. RO is a widely used in desalination of brackish water. To desalinate water, it is required to create flow through a membrane, causing the water leave the salt side of the membrane, passing into the unsalt side. To achieve this, pressure must be created upon a water column on salt side of the membrane. First, to remove the natural osmotic pressure, and secondly to create extra pressure on a water column in order to push the water through the membrane. As the name suggests, reverse osmosis is a osmosis in reverse. Therefore, to decrease the reverse osmosis, it is first necessary to understand phenomena of osmosis, which we have talked before. The reversal of natural process of osmosis, it is required to overcome the osmotic pressure, right? So it is required to overcome this osmotic pressure equilibrium across the membrane, because the flow is naturally from the dilute concentrate. We want more pure water, and so we must increase the salt content in cell side to do the increase the pressure on salty side of membrane and force the water across. The amount of pressure is determined by the salt concentration. As we force water out, the salt concentration increase, requiring even greater pressure to get much pure water, because the salt uh, at surface of membrane are accumulate and block these pores. So we require large amount of pressure for the to get the pure water, right? So in reverse osmosis, we require higher pressure compared to the other all membrane separation process. Typically, reverse osmosis system consists of three components: pre-treatment, membrane assembly, and post-treatment. Now let's discuss about the various advantages and disadvantages of reverse osmosis. Removal of nearly all contaminant ions and most of dissolved and non-ions from the reverse osmosis, which is the advantages of reverse osmosis. Reverse osmosis relatively insensitive to flow and tedious as like the ion exchange, thus is sustainable for the small system with high degree of seasonal fluctuation in water demand. That's why we have used reverse osmosis at home or domestic purpose. RO operate uh, RO can operate immediately without any minimal break-in period. Low effluent concentration possible in a reverse osmosis. Bacteria, viruses are mostly removable from the water. Operational simplicity and automation allow for the less operational attention for this plant, and are suitable for the small system application. Now, what are the various limitations for the reverse osmosis? Higher capital and operating costs are required for the large capacity plant. Then managing the wastewater is a potential problem in reverse osmosis, right? So managing wastewater or brine solution which are removed from the reverse osmosis is a very big problem in reverse osmosis. High level of pre-treatment is required in some case, and membrane are prone to be a foul, right? After some time of period, all the membrane are going to be a foul due to the concentration or accumulation of solute on the surface of a membrane, right? So this is about the reverse osmosis. Now let's discuss about the electrodialysis. Electrodialysis is an electromembrane process in which ions are transported through an ion exchange membrane from solution to another influence of electrical potential gradient. The electrical charge on ions allow them to drive through the membrane, fabricate from the ion exchange polymer, applying a high voltage between two end of electrode, right? So here we can see the two end of electrode, one is a anode and second one is a cathode. So during the transportation of anion are able to permeate through the anion selective membrane, right, like this anion selective membrane, and cation pass through the cation selective membrane. So AM, which represent as the anion membrane, CM, which represent cation membrane. As a result, two different solutions are produced inside this stage. One which are more dilute and other one are concentrate than the feeding solution. Since the membrane used in electrodialysis have a ability to selective transport ion having positive or negative charge and reject ions of opposite charge, useful concentration or removal or separation of electrolyte can be achieved by the electrodialysis. Using right combination of anion exchange and cation exchange membrane, the ions of feed solution can be separated. The desalted stream is known as a diluent and concentrated stream is known as a concentrate. Electrodialysis takes place in electrodialyze the equipment which made of two electrode, one is a anode and one is a cathode, right, which show in this figure. The usually reaction at cathode that can be given by 2H2O plus 2 electron gives H2 gas plus 2OH minus, right. For this we require the some amount of energy in form of the electricity. The OH minus form must be neutralized in a cathode component. Cathode can be made of the titanium, right. Now at cathode anode usually reaction is in anode part, the reaction is H2O minus 2 electron gives 1 by 2 O2 in gas form, right. So these both are in gas form. So where the electrode potential are standard value at 25 degrees Celsius, 1 molar solution of ions and partial pressure of 1 atmosphere for gaseous product, the value of energy can be corrected for the non-standard condition by the equation. The corresponding overall cell reaction that can be given by 3H2O gives H2 gas plus 1 half O2 plus 2H plus 2OH minus, right. The anode can be made from the same material as the cathode or from the stainless steel. The anode and cathode component are separated from the stack by the membrane. These compartments are vented to remove gas form. In practical, electrodialysis system operate at 200 to 400 cation and anion exchanger membrane are installed in parallel fashion to form electrodialysis stack. Each stack contains 100 to 200 cell pair. Electrical energy consumption in electrodialysis is about to 1.6 to 2.6 kilowatt per meter cube, right. So this much amount of energy is required. The product water from feed having has a 1500 to 2000 milligram salt per liter. To acquire product out of one part of solution, whatever is a diluted or concentrate, only can be a goal of electrodialysis, but sometimes quality is required of both product, especially when treating wastewater. Diluted must be completely with the regulation of GPCB and CPCB, so that electrodialysis are mostly used for the particular separation of a particular ions, right. So what are the various advantages and disadvantages of electrodialysis? Let's first discuss about the advantages. All contaminant ions and most of dissolved non-ions are removed. Second, relatively intensive to flow and TDS level compared to the reverse osmosis and ion exchange. Low effluent concentration possible. What are the various disadvantages such as the high capital and high capital cost required? Operating cost is high because of the energy consumptions. High level of pre-treatment required. Reject stream is a 20 to 90% of feed flow, right, which is a higher than the reverse osmosis. Electrode are required replacement after some period of time. Again, one more advantage such as membrane which are used in this electrodialysis is also going to stand for the fouling. So we also require to replace that membrane. So these all are the various disadvantage of electrodialysis. So this is all about the today's lecture. I am completing my lecture here. Thank you.